So, hello those who wanted to see this session. I think probably I got put in this room because I've done two things in the presentation title. I mentioned DevOps and containers. And certainly it seems to be the theme of anything around OpenStack at the moment when people are talking about these things. But I'm very sorry if you're expecting me to teach you about Kubernetes and how to use it or how to drive these things, because this session is actually more about thought leadership, about how you might develop the capabilities you've got today using OpenStack and how you might think about the future and the way OpenStack can grow with you as an organization and enable more capability as you move forward. So it's really about where next, and some of that story is about containers. We do go into Magnum, the project in OpenStack that's been mentioned a lot at this event already. And I'll give you a brief show and tell about that. I was going to do a demo until I realized the kind of room I was in. You might have noticed I haven't got a computer, so a demo might be quite difficult. Sadly, I've had to replace that with screenshots, but we'll move forward. I am the Souza EMEA OpenStack technical strategist. It sounds very grandiose, but essentially I help the local guys in Europe, Middle East, and Africa, the local technical sales engineers, understand better how to take OpenStack to their customers. And then a really big part of my job is feeding back from the likes of you, the companies who are thinking about using OpenStack with Souza, about what the key features and the things that you want to use and the capability. And some of this presentation will actually deal with the learning Souza has made whilst dealing in the OpenStack organization. So first of all, I need to work out how to use my slide deck. I got told it was tricky. The poor lady this morning was also struggling. There we go, right, so we've gone straight through. How do I go backwards? That way. Right, so I'm going to first of all do a quick kind of scene set. Why would it be OpenStack? Sometimes at these events there's people who are looking to actually understand what OpenStack might bring them. So it's beholden on me to explain that very quickly. Really go into what Magnum allows you to do around containers, and then talk about what implications that has to our thinking as architects when we're building out OpenStack solutions for customers. So they're essentially the subjects that we'll walk through. And first of all, a very challenging marketing side. Why aren't you driving OpenStack? It's very bold and strong, isn't it? But really, the argument there is an argument from Souza that OpenStack's now mainstream. Okay, now this probably started happening 2 years ago. Up until then, it was really an incubation for a lot of people who were working with it. There was some very technically strident individuals taking OpenStack services forward, but it wasn't that common in the mainstream for organizations. There was lots of laggards around the technology. Very recently, Souza's been doing some surveys and some analysis of its customer base, and we're seeing OpenStack in production more and more. So essentially, it's just a validation that it's very, very powerful and it's ready for prime time in organizations. Lots of organizations getting the benefits of cloud orchestration at mega scale from their own data centers using our technology, okay? We've also seen some other interesting things using this technology stack and the analysis we've done around it. And one of the really interesting things is containers seem a very good idea to lots of organizations. So this buzzword at the moment of microservices and wrapped around the DevOps story, yeah, it makes a lot of sense. And we'll go into that in a little bit more detail in a moment. But we're finding that organizations that use OpenStack, because they're already thinking software definition for their infrastructure, are finding it much easier to onboard Kubernetes or other technologies for administrating containers at cloud scale. And they're able to drive it faster and adopt it quicker in their organizations. And it's really a validation of OpenStack being that very versatile orchestration layer for the services that customers are now demanding of their cloud provider, which you will be whether or not you're delivering to your internal customers or your external customers. So, the key argument here is a slide we borrowed from the Austin OpenStack Summit. So this was the theme of Austin over in the US about a year and a half ago, maybe. And really, they were talking about 3 types of workloads. So you've got your standard hosted workloads, which would be your traditional VMs that you transport into your cloud infrastructure to deliver a cloud scale. Then you optimize some of those solutions, so make them more effective at running in your cloud, so they're cloud optimized. But they're really where organizations are starting to think is work towards cloud native as an application set sitting on top of your private cloud. And that's really where the conversation about containers start to happen. And Jonathan Bryce at the time, the executive director of OpenStack, did reinforce the idea that without being able to deal with all 3 of those use cases, OpenStack would become another silo. So you would have your VM silo delivered in cloud and you would have your containers silo. Well, really, wasn't the idea of OpenStack to get away from a siloed division of services that you were driving out as an organization? Souza, a little bit of an advert. We have paid to be sponsors, so quick advert. We have a very powerful OpenStack cloud. And these are some of the features that we call out when we're talking to people about Souza. This session really isn't about Souza. So really, the reason why I wanted to put it up there is Souza has always focused in on what OpenStack's been delivering. So in our version we've got today, we've concentrated very heavily on interoperability, the ability to upgrade without disruption. So even though CERN were very thoughtful when they set up their OpenStack clouds and put their control services into a virtualized plane, not many organizations did that. So many people suffered great pain when upgrading back in the earlier versions of OpenStack. Now, Souza's worked very hard on making that upgrade cycle very easy for organizations that work with us. We've got wide hypervisor support, etc. But really, that's all focused in on the traditional idea that OpenStack should drive virtual machines. How does that fit when you've got a model where we are talking about much more agile capabilities within our platform? So moving through that hosted through to cloud native solution. And really that's where this slide comes in. So just to explain, we're talking about physical infrastructure being abstracted as virtual systems by an orchestration layer of OpenStack. But it's really what I wanted to point out is it's the services on top that matter. As a guy who works a lot with Souza OpenStack Cloud, I don't care. It's not my job really to help my customers become experts in building clouds. It's my job to make my customers experts in delivering the services on top. And that's what these might represent. And there's many other use cases, of course. It's a very general capability. But ultimately, containers are one of those solutions that an IT organization might want to offer out to some of those who might use their cloud services. Now, that might be because some software vendors are delivering containerized applications nowadays. Some of the standard application sets are already being containerized and being available to you as customers for running them. But more often, that capability is demanded when organizations move to this mythical DevOps unicorn that everyone likes to talk about at the moment. So essentially, what is DevOps? We know it's the bringing together of 2 disciplines within the IT department to try and break down walls that traditionally damaged our effectiveness at delivering quality services to our customers. That's really the idea behind it. And this is an image of trying to show that at Souza we're concentrating on the fact that this thought process should permeate everyone's approach when they're thinking about where services will go when they become that cloud native. Okay, so it's a continuum, obviously, an 8 on its side, if you want to think of it that way. But essentially, it's an ongoing process where we are continuously integrating small amounts of change into the production layer via test. Okay? Now, that's where containers really become very interesting to organizations. So, I've talked about OpenStack being a great tool for driving VMs. We've been using Nova for a very long time to drive our virtual machines on KVM or other hypervisors are also included. But when you do that, you have an overhead. That overhead costs time, it costs energy, it costs resource. And ultimately, that overhead is the fact you are replicating the operating system capability when you are bringing up that virtual instance. You are mimicking the machine that virtual machine resides on. You're mimicking the hypervisor. Now, with containers, you are able to avoid that very expensive resource tier having to be dealt with. So when you're working with Linux application containers, a lot of people talk about the upstream project of Docker, you're actually getting away from having to build that underlying infrastructure piece each time you start up your virtual resource. Well, if you think about that in a scale terms, I've been talking about Webscale. Suddenly that becomes really powerful. Not only are you able to work towards a DevOps model where you're using continuous integration, but you're able to spin up virtual resources very rapidly, very intensively on the facilities you've got within your data center. And effectively, you can go to mega cloud scale very easily across an infrastructure pool that traditionally would have been impossible using a virtual machine resource. For the developers, it's ideal because it's very portable. It's very rapid to use because you haven't got the overhead to set these things up. So it becomes a very powerful medium if you are moving towards that DevOps model. It's not critical or required because DevOps is a philosophy rather than actually a true defined process, but it is a very useful tool using these kind of concepts. Well, obviously, when you're able to do that, you're able to move into quite a halcyon or wonderful Nirvana stage where you end up being able to get to this cloud native logic where you don't actually build resilience by building bigger VMs or making those virtual machines highly available in the traditional virtualization sense. What you do is define multiple instances of the particular service to be available at any one point in time. So if you lose some of the containers, it doesn't matter because the orchestration layer that's driving the containerization will just spin up more and replace them. So you can genuinely go towards a logic of zero downtime much more effectively, but also be able to spin out in scale. That agility to drive out new virtual resources is scalable beyond any imagination of traditional virtualization. It also adds other benefits. So I was earlier mentioned about Ceph virtualizing their control plane. And if you do that, you do get benefits in being able to manage it from an upgrade process, manageability process. Well, if you combine containers into that model and move some of your control services across into that OpenStack control tier, and some of you may be aware there's a couple of projects going to help you around that. Cola and Courier give you some capabilities there, then you really are getting to not only having agility on the services you're driving out to your customers, but actually gaining that efficiency in your own data centers as cloud managers and cloud administrators. Obviously, all these things enhance any solution that you've got working forward. But essentially, it uses some form of container orchestration. Now, at Souza, we've concentrated heavily on Kubernetes. There are others. There are Swarm. There are Mesos. We actually concentrated on Kubernetes because we felt the industry was telling us Kubernetes was the critical one. And actually, very recently, some press announcements of different organizations have validated that thinking, if you keep an eye on the IT press. But ultimately, that doesn't matter. That's a religious war. I'm just going to talk about Kubernetes because it's a thing that is familiar to me individually. So just replace it with the orchestration layer you would like to use. But essentially, it's a way of scaling. You build those rules of flexibility and elasticity in at this cloud orchestration or containers orchestration layer, which gives you the flexibility that I was talking about. But how do you get that capability of your container orchestration layer and drive it through the power of OpenStack. And that's that Magnum project. It's very portable, very powerful. And actually, there's some good demonstrations by some of my development teams at Souza. So Souza's been doing DevOps long before DevOps was thought of, as many organizations. We're a software house, okay? We've been very agile in the way we've been developing solutions. And some of our guys now are developing a containerized Kubernetes-based solution, which is standalone away from OpenStack. But interestingly enough, those developers actually use Magnum to build the environments for all their different developers to build their standalone container solution. And the reason is it's much more understandable, much more rapid, much easier to drive through Magnum a definition of what a cluster might look like, and then allow Magnum's APIs to drive out what the Kubernetes layer needs to be underneath. And actually, that was going to be my really powerful demo for you all, where I just literally, with a click of a button, I'm able to bring up virtual machines that you can then drive through the API to Kubernetes to instantiate any Dockerized application set that you might drive. And within Magnum, that is a really powerful solution. How it actually works is that the OpenStack Magnum cluster will be developed. You actually build a template. I've got a screenshot of it in a little while. But as an OpenStack user, you're able to define what your cluster needs to look like. You then drive that through. It's a heat template in the background, but to some degree that's masked from you. You drive that out through your scheduler, and the containers cluster of Kubernetes builds a master and some minions, or multiple masters because you want resilience in your containerized application, and some minions beneath. Within those minions, you have a concept of pods. Minions are workers, in effect, in the Kubernetes world. In those pods, you can run multiple containers. So a pod's a grouping logic saying that if I need server service X, I need it to reside in a pod with server Y to make it more effective and manageable. That solution is literally built on a click of a button. It takes seconds, once defined, to repeat that. Then with the multi-tenancy capability with OpenStack, you can repeat it across multiple different parties. So if you have many developers, they can individually be tenants who have got the ability to stand up these Kubernetes clusters rapidly for their development operation. Or if you've got multiple business units who are all developing, they could be individual tenants. But each one of them can benefit from the cluster definition the others got, really moving towards that idea of the software-defined infrastructure layers. So I was going to do a demo at this point. These are the screenshots. They're not quite as sexy. To suffice to, if you find tech sexy, I guess not everyone does. But you define your cluster, you then drive, hit create, and that is driven out into your OpenStack infrastructure as a resource. This is a view of the Horizon network topology of all the individual pieces, and really it describes how complex it is to build Kubernetes without Magnum. Okay, so each one of these services has to be defined for Kubernetes. And then if you do it outside of Magnum, you're going to have to define another cluster for your next user. Now, you might be able to use the definition scripts that come with Kubernetes, of course, but you've got to go through the process over and over. With OpenStack Magnum, it is just a direct click of a button. Those resources are available. And in the background, Magnum actually can drive not only virtual machines to then use as your containerized platform, but it can actually drive ironic instances as well, so bare metal, where you really want to narrow down on the resources to take control of exactly what you're driving your containers upon and remove any overhead. It's a choice to any organization. Really, I wanted to illustrate then, where does that take us? So yes, Magnum's important. It's available today. It's been available for a while. But really, we need to think about where it's going to take OpenStack in the future. So I've mentioned the fact management and supportability is a key element of OpenStack. For anyone who's had to upgrade OpenStack that's been critical to their business services, and it's been a bare metal instance, I'm sure you've all had some pretty sleepless nights trying to get those things to work in the past. When you virtualize, containerize, things become a lot easier. So when you work towards this day 3 challenge of upgrading your solution, it should be a more simple process, much less risk-filled process as administrators to go through. Obviously, you're abstracted away from that, so you have to think about how you're going to monitor those solutions. And there is ways to monitor them as well, but I haven't got time to go into those things. I have less than 5 minutes left to me at this moment. HA is a key component, or high availability within OpenStack. Florian Haas mentioned it earlier in the keynote session. The high availability of the services that you have running, I think I've lost my mic, but so high availability on the services that you have running, is that better? Is an important feature. So even though I actually subscribe to the pets and cattle argument that your virtual machines are no longer your pets when you move to a cloud world, worry about them less, move towards an idea where they're cattle and they're just serving a purpose for you. And actually that becomes even more important when you're running containers on top of your OpenStack, because obviously the whole idea of containers is they are able to cope with failure and just act as the Borg basically and just create more of them to replace the one that's fallen. But actually on the control plane, it's very critical that your service is your pet. You need to keep it alive. You need to keep it fed and watered. And the traditional approach in OpenStack has been HA. So HA proxy is used by many solutions, including Souza OpenStack Cloud. That HA capability can run across your virtualization. But actually, if you move to containers in your control plane, you don't have to worry about the baggage of that HA layer. You can build your control plane with your Kubernetes logic or your container orchestration logic, obviously, to be able to cope with failure. So you move away from the challenges that many organizations have felt when administrating the HA on the bare metal for their OpenStack control plane. So that's another useful element to it. I did mention earlier the bare metal capability, ironic, so the ability to drive bare metal as a service becomes even more interesting when you think about containers on top of them. So Magnum can drive virtual machines, but it can also drive onto bare metal servers. So that's a very interesting technological move as well for your architecture as you're moving forward. Obviously, there's advantage there. You remove the virtualization layer, so you are taking some latency out of the process. The noisy neighbor argument isn't so strong to me personally. Somebody else wrote this slide. I think actually if you've got loads and loads of containers on there, all challenging from resource, you're going to get noise. That's the nature of a virtualized environment. But essentially, Ironic does offer a lot of capability to broaden your architectural capability within your OpenStack layer. So just to do another quick Souza commercial, I know I've mentioned it a lot, and it is an open source event, but just to say Souza does see the future around containers. Others might not, but Souza do genuinely see containers being a very important part of the next 10, 15 years in IT service delivery. And because of that, we've concentrated very heavily on it. The picture here shows the different solutions that Souza brings to market nowadays on top of open source. So we sell support and management of these layers. Obviously, we've had the infrastructure. We've now got into storage and software-defined networking. We have OpenStack and have had for a long time. You can run Magnum on top of OpenStack, but we have actually recently announced a platform to run bare metal containers if actually all you want to do is run containers in your cloud and you don't want the benefit of Magnum allowing you some extra sophisticated capability around network management. It's particularly challenging around containers, volume management, storage management, things like that are challenges in traditional bare metal containers. And as such, you might look towards Magnum to facilitate that capability. I'm down to 23 seconds. Anyone got any questions?
Is there any question then?
It was probably good I didn't do the demo because I would have got nowhere near the 25 seconds. But please shout up if you have any questions.
Yeah, I will give you. Oh, wait.
Yes. So the question was, what's the relationship with Helion? So the relationship with Helion is HPE decided to disinvest, if there's such a word, around OpenStack. So they've decided as a corporation to move towards what they perceive as their core business. Souza and our parent company, Micro Focus, are very close to HPE. There's no secret behind that. And Souza saw the opportunity to take some very good open source, OpenStack capability in-house and expand our capability, our reach. So our OpenStack developers, I always make the joke, they're like hen's teeth. I don't know how many hen you've seen with teeth, but good OpenStack developers are generally employed and happily employed by their employer. So to be able to bring Helion into our organization was a massive boon for Souza. We are taking the code bases and driving them together. So in the next release of our OpenStack capability, it will be the same code base for both Helion and OpenStack. But Helion as a brand still exists, and if you want to buy it from HPE, they'll be more than happy to work with you. It is essentially an OEM brand of what will be Souza code moving forward from now. Does that answer the question?
Any more question then?
So you're free for coffee?
Yep. It's going to be served in 10 minutes.
Oh, 10 minutes, because we started 10 minutes early.
Yeah, we started 10 minutes early. Yeah, and then the next one, the next session is going to be at 3:20. So, yeah. Enjoy your coffee.
Thank you very much.
Thank you.